Hello everyone, welcome back to Emmanuel Tutorials. Today we'll be seeing a sketch the signal example asked by one of our students in the comment section. If you also have any doubts related to signals and systems or any other electronics or computer science engineering subjects, you can ask them in the comments and we'll try to help you with that. If you have not subscribed to Emmanuel Tutorials yet, do subscribe and do like and share this video with your friends who are in need. So let's start. This is a ramp type of signal example. So all the signals that we have are ramp type. So first we have 2r of t plus 5 minus 4r of t plus 2r of t minus 5. So you know that the ramp signal is a 45-degree line across the x and y axis, positive x and y axis, that is the time and amplitude axis, and which has amplitude of t at every point in t. So at t equal to 0, amplitude is 0, at t equal to 1, amplitude is 1, and so on. And if you want to draw r of t plus 5, this is a advanced version of the ramp signal. So you'll be shifting it to the left by 5. So the signal which is starting at 0 will start at minus 5 now with the same amplitude. So I'm just shifted the original ramp signal to minus 5 and the amplitude is going to remain the same. But if you see, we have also an amplitude scaling by 2. So this amplitude that are present at each of these points, that is minus 5, minus 4 and so on, we are going to multiply by 2. So at minus 5 amplitude will be 0 into 2 which is 0. At minus 4 amplitude will be 1 into 2 which is 2. At minus 3 amplitude will be 2 into 2 which is 4. Minus 2 it will be 3 into 2 which is 6 and so on. This will continue till infinity. So this is our first part of the signal, which is 2r of t plus 5. Now about the second part. Second part is a 4-time amplitude scale version of the ramp signal. So if you see our original ramp, we are going to just amplitude scale it by 4. Meaning at t equal to 0, our signal will be having amplitude 0 into 4 which is 0. At t equal to 1, amplitude will be 1 into 4 which is 4. At t equal to 2, it will be 2 into 4 which is 8 and so on. This is also going to continue till infinity. Now what we have to do is first subtract this signal from the first. Now when we do that, if you also might have seen our previous videos, I have mentioned that if we don't have a signal for a particular duration and the first signal and you're subtracting the second signal from the first, you can draw the first signal as it is. So what I have done is, this is our 1 minus 2. From minus 5 to 0, you can see second signal has nothing or it has amplitude 0. So I have just drawn the first signal as it is. So from minus 5 to 0, our amplitude is going to be 2t. That is what I have drawn here. So at 0, our amplitude is going to be 10 because this will be 5 into 2 which is 10. So it is 10 over here. This part will not be there. And at 0, second signal's amplitude is 0, first signal's amplitude is 10. At 1, first signal's amplitude is 12 because it's going to be 6 into 2. So 12 minus, second signal's amplitude is 4. So 12 minus 4 is going to give us 8. So at 1, our resultant signal's amplitude is going to be 8. And if you see, the angle or the slope has changed. So this is also going to be a inclined type of signal, not a straight DC type. If both of our slopes were same, it would have been a DC kind of signal. And next, at t equal to 2, first signal's amplitude is going to be 14 because 7 into 2 is 14. Second signal's amplitude is going to be 8. So 14 minus 8 is 6. So our amplitude is going to be 6 for the resultant signal. Similarly, it will be 4, 2, 0 and so on until infinity. So this signal is going to continue till infinity. So this is our subtraction of first and second part of the signal. Now remains the last part, which is 2r of t minus 5. 2r of t minus 5 will be similar to this first signal, but only thing is here we are delaying it, or here we are advancing it. In the second part you are going to be delaying it. So the signal is going to shift to the right by 5. So our signal is going to start from 5, ramp signal, and it's going to be still be an amplitude scale version. So the same signal can be drawn at 5. That is what I have drawn here. So this signal at 5 amplitude is 0, at 6 amplitude will be 2, at 7 amplitude will be 4 and so on. Now if you see both of these signals, you have to add both of these, right? So these two need to be added to get the resultant signal. From minus 5 to plus 5, second signal has nothing, or it is 0, amplitude is 0. So you can draw the first signal as it is. And second, for t equal to 6, if you see first signal's amplitude is minus 2, second signal's amplitude is plus 2, even though it's not so properly visible here. So this is minus 2 and this is plus 2. Similarly at 7, first signal amplitude is going to be minus 4, second signal's amplitude is going to be plus 4. So when you add both, these are going to negate each other and it's going to cancel out each other. So at 6 it's going to be minus 2 plus 2, which is 0, again then minus 4 plus 4, which is 0. So from minus 5 to infinity, what you are going to observe, the behavior is going to be zeros. So in our resultant signal we are going to get only this part of the signal, that is from minus 5 to plus 5, a triangular signal. That is what I have drawn here. This is our resultant x of t with maximum amplitude 10 in the between, that is t equal to 0, and it's going to start from minus 5 and end at plus 5. Hope you understood this. If you have any doubt related to this video or any other concept in signals and systems or electronics or computer science engineering, please let us know in the comments and we'll try to help you. Thank you for watching.